Alright, this is Mr. Clancy. This video is about atmospheric convection currents. And specifically we want to discuss four properties that air has that determine basically how it circulates within our atmosphere. Alright? The first one is its density. I'm going to kind of space these out that I listed so I can put some annotations in between. Alright, the second one, alright, is its water vapor capacity. Alright, the water vapor capacity. The third factor is something called adiabatic heating or cooling. Heating or cooling. All right. And the fourth one, a little space down here, I'll have to move, basically would be something called latent heat release. All right, so a couple of things here. Let's look at this here. The density of air. I think we know that warm air at the constant atmospheric pressure, basically warm air rises. It's less dense. All right, and cold air falls. All right, because it's more dense. All right, and whether this is a room in your house or the atmosphere, you can see this warm air is going to rise from the bottom story of a house to the top story of a house, or it's going to rise from the surface of the earth up into the atmosphere as it rises in the what we call the troposphere or the weather layer. The density, this is a key factor in circulation. All right. The second one, water vapor capacity. All right. Water vapor, the capacity, warm air has a much higher capacity for water vapor than does cold air. So we'll say warm air holds more water vapor. All right, and so if this happens, all right, then you can certainly, we're familiar with those warm summer days, those real hot summer days that are very muggy because the humidity, which is the amount of moisture in the air, so we'll say warmer air is more humid. All right, so that warm air is extremely humid, and the maximum amount of water vapor that can be in the air at a given temp is called its saturation point. So let's make a note of that saturation point. All right, the maximum amount of if you will, of water vapor that can be in the air at a given temperature. Of water vapor that can be in the air at a given temp. All right, so given temperatures have different saturation points. All right. right? So basically, as the temperature of air falls, its saturation point decreases, and the water vapor that's in the air condenses into liquid water.